Hello, scholars, and welcome to part 3 of the geometry final exam review. I am a little sick today, so excuse that stuffed nose, but let's get into number 21. So it says determine the equation of the circle graph below. So first we're going to start off with our standard equation of a circle, which is x minus h squared plus y minus k squared equals r squared. This is probably a formula that you should have on your cheat sheet. Just a little piece of advice there. So once I write my standard equation of a circle, I'm going to determine my center. So my center is going to be in the middle here. Looks like it's right here. And that looks like it's 2 comma negative 5. So I'm going to write x minus 2 plus y, and then minus negative 5 would be plus 5. And my radius is 4, so 4 squared is 16. All right, same thing for number 22. I always start off with my equation, so x minus h squared plus y minus k squared equals r squared. My center is right here, so it's going to be x minus 1 squared plus y minus 7 squared. And the radius is 3. 3 squared is 9. So remember, my center is h comma k. That's how I filled in the h and k for both of these, right? The center was 2, negative 5. So I just replaced h and k with 2 and negative 5. The radius was 4, so I replaced r with 4. Same thing right here. Center is 1, 7. So I replaced h with 1, k with 7, and the radius was 3, so 3 squared is 9. All right, moving on to 23. So in circle F with the measure of angle EFG being 110 degrees, find the angle measure of minor arc EG. Now, is this a central angle or an inscribed angle? The vertex is in the center, in the middle here, so it is a central angle, and these are equal to each other. So the central angle is just equal to the arc, right? Inscribed is half the arc, central is equal to the arc. So it is 110 degrees. All right, number 24, which segment is the hypotenuse? Hypotenuse is always across from the right angle, which is right here. So the hypotenuse is FW or WF, which is letter B. It might ask you about opposite and adjacent on the exam. Just remember that hypotenuse is across from the right angle. Then it's going to give you a specific angle. Whatever is opposite, right, across from is opposite. Whatever it's next to is adjacent. All right, so number 25, in circle S with the measure of angle RST being 106 degrees and RS, the radius being 20, find the area of sector RST. So our area of a sector is going to be our angle over 360 times our formula for area, which is pi r squared. So our angle is 106. It's going to be over 360 times pi. The radius is 20. So 20 squared. 20 squared is 400, or we could just type in 20 times 20. So we're going to get our calculator. First, we're going to divide 106 by 360, hit equals, then times pi key. Like I said, times 20 times 20, or just if we know 20 squared is 400, I'm going to type in times 400 equals. And that gave me, there we go. We want a decimal here, not something in relation to pi. So that's going to be 370 point, and then it's the nearest hundredth. So this one's a little weird. It's 0.009, which means this rounds to 370.01. This is units squared. Okay. So I'm going to show how to round that. Again, on the exam, I keep repeating this, but on the exam, it's multiple choice, so there's not going to be any sort of question about rounding. So just, make sure you know how to type in, your formula into the calculator, and you'll be fine. All right, so number 26 is we are finding area of a sector again. So same thing, I'm going to have angle over 360 times pi r squared. My angle is 84. Pi does not change, and the radius is 5, so 5 squared. So how we put this in the calculator is 84 divided by 360 equals times pi times 5, which is 25. So I'm going to put in times 25 and hit enter. And I get 18 points, and then to the nearest hundredth is 0.33 units squared. All right, moving on to 27. Now we are solving for x, which is this hypotenuse of this triangle. We're given a side and we're given an angle. So therefore, and actually since it's 45, this one might look like a special right triangle, but just use SOHCAHTOA. This might have been just a weird question. I mean, technically we can use the special right triangle, but just let's use SOHCAHTOA because on 27 on the real test will be SOHCAHTOA, I'm pretty sure. So now let's label. So this is the angle we're given, right? 45 degrees, which means that's how we're going to label the H, O, and A. So this is the hypotenuse because it's directly across from the right angle. Directly across from our angle is going to be our O, and right next to our angle is going to be A. And see how they're giving us O and H, right? So that means we're going to be using sine. So sine of X is equal to O over H. And now we're going to fill in. So 45 degrees is our X, 67 is our O, our H is X. And now we're going to use butterfly, which means it's going to be sine 45 times X is equal to 67, right? So if I put this over 1, that's how I got butterfly sine 45x times 67 times 1. And then I'm going to just rewrite this as dividing by sine 45. I'm going to write it over here too. So x is equal to 67 divided by sine 45. All right, because once I have my butterfly, I still have to get x by itself. So I'm going to divide both sides by sine 45. So I'm going to put in the calculator is 67 divided by sine 45 and see what I get. So 67 divided by sine key, put in 45 and hit enter. And I get 94 points, and I'm rounding to the nearest tenth, so that's going to be 0.8. 94.8 is our answer for that one. All right. Again, when we see a right triangle and we see an angle and a side, right, we're going to be using SOHCAHTOA. All right, so for 28, this is, it's going to be the same thing, it looked like. Yep, 28 is the same thing, so let's write SOHCAHTOA. And let's label. This is our angle right here, so this is our hypotenuse. This is our opposite. This is our adjacent. Okay, that's an H right there. All right, so it's giving us A and O because it's giving us 56 and X there. So I'm going to be using tangent. So tangent X is equal to O over A. All right, so we know our angle is 43. We know our O is X, and we know our A is 56. And now we butterfly, or just the opposite of dividing by 56 is times 56. So X is equal to tangent 43 times 56. Now make sure you're careful when you put this in the calculator, right? We're going to click tangent. I'm going to put 43, and then we're going to end parentheses. Then say times 56. Hit equals, and we get 52 point, the nearest tenth would be 0.2. All right, make sure you close the parentheses right here at the 43 so you have an accurate answer. All right, so 29. This is our part of our similarity unit, which is basically these, when we kind of divide this up, it becomes proportional. So x over 14 is equal to 18.7 over 9.3, right? This side, which is going to be x over 14, is equal to this side, which is 18.7 over 9.3. We're going to butterfly, so 9.3 times x is equal to 14 times 18.7. So let's put that in our calculator. 14 times 18.7 is equal to 261.8. Now I'm going to divide both sides by 9.3. And we get, oops. Let's see, sorry, I lost my calculator app. There we go, 9.3 equals, so 28 point, to the nearest tenth, that'd be 0.2. All right, and last one of this section, we're going to find the value of cosine f rounded to the nearest hundredth. So f is right here. Let's label. H, O would be here, A would be here. We can also write SOHCAHTOA, so that helps us. So cosine we know is A over H. So let's write that. Cosine of f is going to be A over H. Remember, we don't know what the angle is, but we can just write it as a ratio, right? Our A is 30. Our H is 34. And it says rounded to the nearest hundredth, so that means it's going to be a decimal. So 30 divided by 34 gives us 0.88. All right, that's it for part 3, and I will see you for the last part in a minute. Bye.